All right, guys. So we're going to jump into 17.1, which is, Unit 6 is astronomy. So not astrology. Astrology is when you think the planets have an effect on your mood and how you're acting. Astronomy is the planets and looking at at space. All right, so first we're going to start with just the solar system in general, talk about Galileo, and then we'll move to planets and then other solar system objects. So, ancient observers noticed that 5 bright objects seemed to wander among the stars at night. So these are mainly the ones they were seeing: Mercury, Earth, Venus, and Mars. They call these objects planets, from the Greek word meaning wandering star. And they named them Mercury, Venus, Mars, Jupiter, and Saturn, and these are all Greek gods. They named them after Greek gods. Galileo made 2 discoveries. Galileo argued that the phases of Venus could not be explained if Earth was at the center of the planets. Now, this is big because up to this point, everybody thought that Earth was the center of the universe and that everything swirled around it. Galileo got in a lot of trouble with the church because they did not like his scientific findings. Of course, now we know that that's very true, and Galileo got, like I said, in a whole lot of trouble for having the idea of a heliocentric solar system, which helio means sun, so a sun-centered solar system as opposed to a geocentric, which is Earth-centered solar system. Second, Galileo saw that there were 4 moons orbiting Jupiter. Galileo's discovery helped prove that Earth and other planets orbit the sun, disproving the earlier theory that Earth was at the center of the universe. So, orbit, remember, is just a path on which something travels like this. So, these are all the different orbits of Jupiter's moon. And Jupiter has a lot more moons than just 4. But, and if you really like Marvel, you can remember that Thanos came from Titan, one of Jupiter's moons. So, today we define the solar system as the sun and all objects that are gravitationally bound to the sun. So we'll talk a little bit more about gravitational pull and gravity in this, and then we'll really get more into it once you get into physical science. The solar system is roughly divided into inner planets, which are the ones that are kind of close to us and to the sun: Mercury, Venus, Earth, and Mars. And then the outer planets, which are Jupiter, Saturn, Uranus, and Neptune. And if you're old, like me, there used to be Pluto here. Sometimes Pluto wavers back and forth between if it's a planet or if it's not a planet, But these are the ones that we're going to focus on, because these are the ones that are in the book. A dwarf planet, Pluto, is the oldest known member of a small group of frozen worlds orbiting beyond Neptune. So it is kind of a planet. Like I said, sometimes we'll call it a planet, sometimes they won't. It just kind of depends. So nothing to write here, but we can see that here we have the inner solar system with the sun, and it's drawn disproportionate. The sun is obviously much larger than that. Mercury, Venus, Earth, Mars, and then we go to Jupiter, Saturn, Uranus, Neptune, and then Pluto. So, Newton's first law, we're going to just kind of graze the surface of this because we're going to deal much more with it when we get to physical science. Newton's first law of universal gravity explains how the strength of force depends on the mass of an object and the distance between them. So the sun is fairly large, right? So since the sun is fairly large, there's our sun, it has a fairly large gravitational pull. Now in relationship, Mercury Venus, Earth, Mars. Okay, these are all fairly small planets. So what happens is, how it works is, the sun exerts gravitational pull on all these objects, and like the Earth, for example, exerts a small amount back. So this gravitational pull helps them stay in the orbits that go around the sun. Boop. So it helps us stay in this orbit. So we exact a little gravity on the sun. The sun exacts a lot more gravity on us, and so we stay in. And then if we really like, boop, a tiny dot, that would be our moon. So we exert gravity on the moon itself, and the moon exerts a little bit of gravity on us, and so it stays in orbit around the Earth. An orbit is a regular repeating path that an object follows in space around another one. So once again, like if this is the moon and here is its orbit, it's just all around. So it can be short, they can be oblong, they do not necessarily have to be perfect little circles. They can be, like I said, oblong or oval shape. They're not going to be like hard edges or anything like that, like something crazy like this. They're usually going to be round-ish. But like I said, they're definitely not perfect circles. They can be all kind of different paths, but they're usually not perfect circles. An object orbits. Let me get rid of this right quick. Nope. No, don't get rid of that. Cool. Alright, anywho, we can see through this. An object in orbit is called a satellite. So, like the sun, or the Earth is the satellite to the sun. Our moon is a satellite to Earth. And there's a bunch of satellites flying around the Earth. You know, if you have like XM in the car, there's a satellite up there for that, and dishes. And if you have satellite TV, there's a bunch of satellites up flying around the Earth at any time. An orbit results from the balance between the inertia and gravitational force. Without the pull of gravity, the planet would travel off into space in a straight line. So once again, like I said, you can see there's two gravitational forces, the sun pulling on the Earth pulling on the sun, and then also inertia, which once again, these two things we will talk more about. Make sure to put this one in your notes. That would be a good question on a assessment of some kind. The orbit of the planet are slightly elliptical, but almost circular. Like I said, the sun is at the point called the focus, kind of the center-ish, if you want to call it. It's usually a little, like it says, a little offset. So circular orbit, and here's the actual elliptical orbit. Okay, but the sun is the focus or the middle. So if I said, who is the focus between, or what is the focus between the Earth and the moon, it would be the Earth. If I said, what is the focus between the sun and Mars, it would be the sun. In addition to orbit, the sun, the planets also rotate. So we have lots of different types of spinning here. So I have spinning around the sun. All right, sorry for my horrible drawing. And we also have the Earth spinning itself. So we have the orbit around the sun, which is one revolution. We know is 365.25 days. That's why we have a leap year every 4 years to make up that. and then 24 hours to spin on its axis here. An axis is an imaginary line from the north to the south. It passes through the center of the planets from pole to pole. So from the North Pole all the way down to the South Pole. But it's imaginary. Alright, so the sun is by far the largest object in our solar system. 1 astronomical unit is the equivalent of 150 million kilometers, or the distance from the Earth to the sun. So, like Mercury's fairly close at only 58 million kilometers. So it's a portion of an astronomical unit, not a full astronomical unit. So, average distance from the sun in astronomical units, obviously Neptune's way out there, Uranus, Saturn, Jupiter, Mars, Earth, Venus, and then Mercury. And then here's the relative size. Like I said, you can see that compared to the sun, Mercury, Venus, Earth, and Mars are tiny. And then Jupiter and Saturn are much larger, but still compared to the sun, it is very, very small. And that's it for this little intro into the planets and our solar system.